Hi and welcome to Unit 1, Topic 3, Video 18. And in this video we're going to look at the three tangent theorems. So what I'm going to do is define and prove the three tangent theorems, and then we'll move on to some separate videos with some examples. Recall that a tangent is a line that just touches a circle. So this tangent AC touches a circle at B. AC is the tangent and it meets the circle at B, that should say B, and the circle has centre O. Tangent theorem 5. Tangent is perpendicular to a radius. So any tangent drawn is perpendicular to the radius of the circle for the radius that touches at the point T. So let's do a proof by contradiction where we've already got S defined. So we're going to contradict that by saying, by assuming the opposite. So we're going to assume that angle OST is equal to 90 degrees. Now, if OST equals 90 degrees, that makes TO, I'll draw this in here, it's going to get a bit farcical, but it means TO is a hypotenuse of a triangle, right angle triangle, and so therefore TO is greater than SO. SO is just one of the shorter lengths. And we're going to contradict this by using a geometrical reasoning type proof, and it's going to be hard to see on here. But imagine if I call this little thing in here, that little extra bit there, I'll call that X. So hopefully you can see, well, TO is equal to R, the radius, and SO is equal to R, the radius, which is up to here, plus X, a little bit more. And so therefore SO is equal to TO plus X, which is just a little bit, which means that SO is greater than TO, which is a contradiction. And therefore, SO and TO, TO must be the angle OTS must be the right angle because we've contradicted the assumption that some other point forms the right angle. So there's theorem 5 proven and through proof by contradiction. Theorem 6, prove that two tangents from the same point are equal in length. So we're going to do this just by a little bit of Pythagoras. And the Pythagoras here is that OR is equal to OT, which is equal to the radius, and OS is common, and we'll let it equal X. And when I say common, it's part of two triangles. So I'm going to show that given where the right angles are from theorem 5, we've got this relationship. OS squared equals OR squared plus RS squared, and therefore RS is equal to the square root of X squared minus R squared. And we also have this relationship. OS squared equals OT squared plus OS squared, and by OS I mean TS squared, and so therefore TS is equal to the square root of OS squared, which is X squared, minus OT squared, which is R squared, and therefore RS equals TS in all cases. And then we have theorem 7, the alternate segment theorem, and this one's the one that's slightly tougher. So in the alternate segment theorem, we use theorem 3 and theorem 2 to prove it. Theorem 3 is the angle inside a semicircle, and theorem 2 is angles at a point, or angles inside a segment are equal. So the angle between a tangent and a chord drawn from the same point of contact is equal to any point in the alternate segment. So the angle from a tangent and a chord, so that is PQ and ST, this is the chord, so that's X, is equal to the alternate angle inside that segment, which is here. We want to show that X is equal to X. So we want to show, required to prove that angle STQ is equal to angle TXS, irrespective of PQ and TS that you draw. So we're going to do this by creating triangle TRS. And in triangle TRS, we know that angle, so here's the proof. We know that angle ST equals 90 degrees. That's angle in a semicircle. And so therefore, we know that Z plus Y equals 90 degrees. So we know that's true because the angle sum of a triangle is 180. Angle sum of a triangle. Okay, so there's some information. And that means that we know that Z is equal to 90 minus Y. Bit of rearrangement. Now, we also know that X, or actually angle TXS is equal to Z, which equals 90 minus Y. We know that to be true because they are angles in the same segment. So this is circle theorem 2. And so because we know this, we've got some information about TXS as 90 minus Y. Now the other thing we know is that angle RTQ is equal to 90 degrees. So angle between tangent and radius, and for you and I, that's tangent theorem 1 that we're talking about there. So we know that to be true, and therefore we know that Y plus X is equal to 90, and therefore X is equal to 90 minus Y, and therefore X is equal to angle TXS, and that's what we're trying to prove. So the STQ, which is X, is equal to TXS, and so the alternate segment theorem is proven. So there's our first video of tangent theorems, and it's just the proofs of the 3 tangent theorems that we'll be using. Remember that the order of the tangent theorems, or theorems 7, 6, and 5, is again arbitrary. It's just the way that I've done it, but that order may not always be true. All the best.